Okay, so today we're going to get into chapter 10, specifically section 10.2, which is simplifying radicals. And we are going to spend the next few weeks on this section. So last chapter we took square roots. We took square roots to solve quadratics when we solved by square roots or when we used the quadratic formula. If our answer wasn't a perfect square, we used decimals in our answers and we rounded them to the nearest hundredth or the nearest tenth. Therefore, our answers were not exact. But we know sometimes in mathematics and science, an exact answer is essential. So, there are ways that you could simplify a radical. You see me using this word radical in the notes and up here in the title. So the first thing I should touch on is a radical is another word for square root. So right now there are also bigger radicals and square roots that you will get to: cube roots, fourth roots, fifth roots, nth roots in algebra 2. But in algebra 1 we just deal with square roots. So for all purposes here, a radical means square root. Okay, and a radical is not simplified is if the radical has any factors that are perfect squares except one. One goes into every number. So any perfect squares except one. Or if there's a radical in the denominator. Now this piece we're not going to be dealing with for a couple weeks. We're going to be focusing on this first bullet. And the one property we're going to be using this week and next week is this one single property that says if you have a square root times another square root, you can multiply the two numbers together and write that as the square root of AB of the product. And in the other direction, if you have a square root of a big number, you can break it down into the square root of two of its factors.